Today's program is Emirp number or Emirp number. This Emirp number is a number which is prime number, and if you reverse that number, it is still a prime number. So basically 17, 71, 13, 31, 113, 311, 1009, 9001. So these both of the reverse and the original number both are prime numbers. So what is a prime number? Prime number is that cannot be divided by any number except one and that number itself. So we have taken an example to show literally that a number is not a prime numbers, and then we have the program here to show the prime numbers. Okay, so this program is not tough, like it is really very easy because prime number is easy. We just need to see how you implement this part and how you manage all of this. Like we just need to see how we manage things. Otherwise the logic behind prime number is very easy. You just iterate from 2 to the last, and like just so let's take an example to understand it. Hi, I'm CGM. Welcome to Education Value. Today we have another amazing video on the Java program, so let's do it. For example, we are taking 17 for example here. If we divide it by each number from 0 to 17 only 2 times, we will get a remainder of 0. I have literally divided it from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up till 17. Only in 2 cases we get a remainder of 0. That means modulus is when we divide it by all that number, modulus is 0 only 2 times in case of 1 and in case of 17. So if we run an iteration or a recursion from 2 to until the 16, like n minus 1, that previous number, so all of them will not give a modulus is equals to 0. So that is the concept that we use to then we implement it using code to get if a number, to check if a number is an Emirp number or not. So let's see the program line by line. So Emirp number, we are using objects here for better efficiency and creating method for each and every different task. So Emirps, we take objects, the object we create another object, we call that object Emirp. Okay, Emirp is called for iterate from number 2 until, like this is used to take the last. This is basically for reversing the number. REVERS. This is basically used for reversing the number. We take the number and run it till it is greater than 0, like till it is 1, and we just then we take the modulus. Like modulus is used to extract the last digit of that number. After that we multiply the ref by 10. So what this essentially does is, for example, we have 17. Okay, so reverse is reverse into 10 plus 1 modulus. So first I is equals to n is 17. I is equal to 17. Originally ref must be 0. Thus ref into 10, it is still 0 plus 7. This will be like modulus by 10 will extract the last digit and it will be 7. So in the next iteration it will be 7 into 10, it is equals to 70. Like it just into 10 just creates a space for last digit to be added in a addition, say whatever it is. Like let's say take the example of 113. First it will extract 3 like I modulus 10, it will be 3. I modulus 10, it will be 3. After that, it will go to it will remove the last digit. Let me show you. Yeah, we have it right here. We divided by 10. Yeah. So when you divide it by 10, you get the last digit in the remainder and the all other digits in the quotient. So we get the quotient in the I, it is called background itself, and the remainder is checked here. So in 17 we have, like, we are taking 113 for example in this case, so 3 is here. In the next iteration it will be 1, and yeah, we already had 3, so 30 plus 1, 31. After that 30 plus 1, 31. We have 31 right now. After that, in the next iteration we have 31 and 1 will come. So 30, 31 into 10, it will again have 310. After that we add 1, so it will keep arranging space for one more digit to be added, and we will keep adding it right there. So this is how basically reversing works. After that, we is prime, we directly call the method and check if the number and the reverse of that number is equals to 0. Is equals to 0 means we are returning, if it is returning it's 0, it's or true or false. So if it is true that if c is equals to 0, return 1. Return 1 is like we have not found the number, and because 1 is generally true, it is a prime number, and if and operator is used, so if both of the cases is true, then we print is an Emirp number, otherwise it is not. At the last we see the public is prime, so it takes 3 inputs, x, s and c. So x is the number which is being sent. 2 is like we were starting from 2 to until the number is less than, if f is like we're increasing 2, so so basically we have to run from 2 to less than that number. So this is the start of the number. Since we are increasing it, so we have to send it in both of the time we are calling that method, because it will be different, like so first we call it for the normal prime number. So 2 is entered and it increases every time we are dividing with each and every number. Like I divided right here for 17, we will be dividing with each of the number between 2 and n minus 1. So the value of f will be better, like it will be more when I will ask it to check for the reverse of the number. So we'll have to send 2 back again, so that it starts back from 2 and not from, for example, here 17 or 13. And the last is 0. Here 0 is like if c is equals to 0, we use 0 for c, so that the count is restored to 0, because each of the time we have to reset both of those digits. So that is very, very important part. Like this is the only logically important thing about this program. Like how you call those, like writing this method is pretty easy. If f is less than x, if f is less than x, until f is less than x, like f keeps increasing, less than f, like 16, like if the number is 17, less than f is less than x, f f is the one with which we are dividing the number each of the time. So until it is less than the actual number, we will keep increasing it. If it is less, like for example we have 2 right now, so it is less, and then x modulus f is equals to 0. If in any case, if ever we find that the number is the modulus is equal to 0, like for example all of the times if it is a prime number, it will never be equal to 0. That is the thing, it will never be equal to 0. So we can just write C++ and check for that. If it's 0, it is a prime. If it's not 0, it's not a prime. So this is the recursion statement. Here the method is called again and again in the return statement, and it keeps calling the loop until this statement is true, and once the statement is wrong, else the base is called and we return either 1 or 0 according to what our statement according to the number, and if it is a prime number or not. So this was the Emirp number. Let's run it once to see the inputs and outputs. Yeah, so this is pretty easy program. Enter the number. I will enter 17 is an Emirp numbers. Let me enter 18. 18 is not an Emirp number. Good. Now let's enter 1009 is an Emirp number. Great. So this was the program, Java program for Emirp number. Hope you liked it. Thank you.